You can take the dead leaves, branches, and organic waste from your yard and turn it into a solid carbon sponge, permanently trapping that carbon underground while significantly increasing your garden's vegetable yield. We are going to walk through the exact steps to safely convert ordinary yard scraps into a highly stable soil enhancer called biochar. To pull this off, you only need 3 things: a steady supply of dry organic waste, a fire-safe space outdoors, and a simple conical metal container known as an open-top kiln. While you can do this in an afternoon behind your house, the chemistry at work here is the exact same mechanism currently being deployed to capture thousands of tons of atmospheric carbon on an industrial scale. This process was actually perfected thousands of years ago by the indigenous peoples living across the Amazon basin. By taking charcoal and mixing it directly with decaying organic matter, they engineered patches of exceptionally dark, highly fertile ground known as terra preta. Terra preta is a Portuguese term that directly translates to black earth, describing soil artificially enriched with carbon. Compare those ancient, nutrient-rich Amazonian plots to the state of many modern agricultural lands. After decades of intensive farming, standard soils often become dry, cracked, and completely depleted of the structural compounds necessary to grow healthy crops. The Amazonian soil survived because of its chemical structure. When organic matter is converted into charcoal, the carbon atoms form tight, highly stable rings that take thousands of years to break down underground. So by burying that carbon, this technique achieves 2 things at once. It stops dead plants from releasing their greenhouse gases back into the air as they rot, and it physically rebuilds exhausted, dead dirt. Step 1 for your own garden is gathering the raw organic waste, formerly referred to as feedstock. Feedstock is the raw biological material used as the base input for a manufacturing process. The golden rule of making biochar is simple. The chemical makeup of what you put into the kiln entirely dictates what comes out. Choosing dense, woody material creates biochar with an incredibly high carbon content, forming a stable framework lasting centuries. However, using softer leaves or dried manure drops the carbon content, but packs the biochar with water-soluble nutrients like potassium, acting as immediate fertilizers. In tropical climates, massive amounts of dry brush, sugarcane waste, and tall grasses are constantly generated, providing a massive, varied supply of this raw material. By selecting the right mix of wood or leaves for your feedstock, you can intentionally design a custom soil additive tailored exactly to what your garden lacks. Once you have your material, you need to execute a specific thermal reaction called pyrolysis. Pyrolysis is the process of heating organic material to extreme temperatures in the complete absence of oxygen. Bake out moisture without letting oxygen reach the core. In a conical kiln, start a small, hot fire at the bottom. Before it turns to ash, drop a thick new layer of feedstock on top. This catches rising heat but smothers the oxygen below. To create high-quality biochar, the internal temperature of that smothered zone must climb above 500 degrees Celsius and stay there. There are 2 main ways this goes wrong. If the fire gets too much air, the wood completely combusts and you are left with useless white ash. If the temperature drops down toward 300 degrees Celsius, the carbon fails to stabilize properly. Hitting that precise thermal window is the difference between sweeping up fire pit debris and successfully locking carbon into a permanent physical vault. When that finished biochar cools and you mix it into your dirt, it introduces a highly porous, microscopic, honeycomb-like structure into the ground. Because of that vast internal surface area, it acts like a rigid sponge. It aggressively holds onto water, traps beneficial microbial life, and stops heavy rains from washing loose nitrogen and potassium down into the groundwater. Because the roots have constant access to trapped moisture and nutrients, fruit trees and vegetables grow noticeably faster and require a fraction of the standard chemical fertilizers. This local effect is currently being replicated on a global scale. Organizations like Biochar are applying this exact pyrolysis method across East Africa, intercepting thousands of tons of underused agricultural waste. They deploy proprietary plug-and-play facilities called agri-carbon hubs directly into rural farming communities, so the waste can be processed locally. This graphic shows the verified results of those hubs in action. They have successfully removed over 1,300 tons of CO2 from the atmosphere, while delivering a consistent 27% increase in crop yields for local farmers. Whether it is a small conical kiln behind your garage or an industrial facility in Kenya, the mechanical steps are identical. By starving a fire of oxygen through pyrolysis, you can reliably force organic waste to convert into stable biochar, capturing carbon that would otherwise heat the planet. In return, your soil gains a permanent physical upgrade. It holds water longer, relies less on artificial chemicals, and produces visibly healthier crops. As you get comfortable managing the heat of the kiln, try mixing different ratios of wood and leaves to see exactly which nutrient profile your specific plants respond to best. You don't have to wait for a massive technological breakthrough to capture carbon. You can put this ancient, verified science to work in your own soil today.